got no roots, but my home was never on the ground. I've got no roots, but my home was never on the ground. I've got no roots. I've got no roots.
What is differentiation? Differentiation is a method used to compute the rate of change of a function with respect to its input, which is x. This rate of change is known as the derivative of x with respect to x. The first derivative of function is denoted dy dx, where dy denotes an infinitesimally small change in y, and dx an infinitesimally small change in x.
What is related rates? In a related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. The procedure is to find an equation that relates the two quantities and then use the chain rule or implicit to differentiate both sides with respect to time. Now that we know that what is related rates, why we use related rates? We use related rates to understand how the rate of change of one quantity affects another related quantity, which is crucial for modeling dynamic systems where variables change over time, such as the inflation of a balloon. They allow us to calculate difficult-to-measure rates indirectly through related measurable rates, aiding in predictive analysis and optimization of processes. This is essential in fields like physics, engineering, and economics for understanding and predicting system behavior.
First, let us start with case number 1. The question is, the side length of a cube are increasing at a rate of 5 cm per second. How fast is the surface area and the volume increasing when the side length is 10 cm? How to answer this question is, first, we need to know that volume of the cube is equals to x to the power of 3. Then, we also need to know that the surface area of a cube is equals to 6x to the power of 2 and the side length is equals to 10. Next, the question gives us the rate of side length increase at 5 cm, which means dx over dt is equals to 5. Thus, we need to differentiate from the surface area formula, which we got dSA over dx is 6 times 2x. To get dSA over dt, we need to time it with dx times dt equals to 5. Then we can get dSA over dt equals to 600 square per second. Thus, the rate of increase of the surface area is 600 cm square per second. Next, by using the same technique, differentiate volume and we will get dV over dx, which is 3x squared. To get dV over dt, we need to time it with dx over dt. Thus, we will get the answer of 1500 cm cube per second. Thus, the rate of increase for the volume of the cube is 1500 cm cube per second.
Next, we will talk about the case 2. So the question is, water is falling on surface within a circular area that is expanding at a rate of 7 mm square per second. How fast is the radius of the water area expanding when the radius is 152 mm? So here is the solution. Based on the question, it already said that dA over dt is equals to 7 mm square per second and R is equals to 152 mm. Since we already know that the formula of area is pi r squared, so we have to differentiate the area. It becomes the dA over dr is equal to pi times 2r. So we flip the equation, it becomes the dr over dA equals to 1 over pi times 2r. Since we already know that the equation asks for the dr over dt, so we have to multiply dA over dt as well. And then for the dr over dt, we will get 7 over pi times 2r. So we have to substitute dr into 152 and the answer we will get is 0.0073 millimeter per second.
The conclusion is, the application of differentiation is used to compute the rate of change. We can accurately count the differences in changes happen. Therefore, identifying the right formula and accomplishing both first and second derivatives correctly will lead to a solid answer, a maximum or minimum cost.